now we're recording. So let me backtrack real quick. We're finding the inverse. I'm so sorry, I forgot to hit record. But these are our steps. Pause the video. Contact me if you need help. Which of these three terms does not have a y? 2x. So we don't need the 2x. I'm going to move that to the other side. Are y'all okay there? Okay. So now, son of a gun, technology, you are killing me this morning. All right, so now does everybody agree we have negative 2xy minus y equals 7 minus 2x? And I'm going to move it so my online people can see. Move y'all's beautiful names. There we go. Okay, and I think this is where we're getting stuck. So what do we do next? Good. You cannot find y equals when there's more than one y. You either try to combine them, which we can't do here because they don't both have an x and a y. So you either try to combine them, and if you can't, then we are going to factor out the y, take out the y, all right? So from here, I'm going to take out y, which means I'm left with what? Good. Equals 7 minus 2x. And then my last step would be to divide. Very good, Mary. Extra credit. Divide the negative 2x minus 1. So your answer, F inverse of x equals 7 minus 2x over negative 2x minus 1. I think when you type in the delta math on your test, I think it'll say F inverse x equals, and then you'll just have to type in the rational part. My online people, does that help? A couple of you emailed me the other day and yesterday and asked for more practice with inverses. So there's one that I would definitely know how to do for the test. Are y'all good with that one?
Yeah.
Okay. Sorry, my handwriting got a little sloppy. A Math 1 kid tried to bait me in one of my videos the other day. She was like, I couldn't follow your video because your handwriting was too sloppy. I was like, bold. Woo! All right, we're good? Okay. So number 2, I think a lot of you were overthinking. So they said we're graphing an absolute value function. So I'm graphing a V. I draw a picture because I'm visual. Is that okay with everybody? And they told us the vertex is negative 1, 4. All right. Then they say, what is the vertex of the function defined as? So we're looking for the vertex. We're not looking for an equation. It says, what is the vertex? And we're looking for the vertex of this graph. All right, so let's talk about it. This is my original vertex, correct? Then it says, it doesn't say the word transformed because that would be too easy. But it says, what is the vertex of the function defined as this? So in this new function, what am I doing to the original one? Ooh, say it again. Somebody said horizontal reflection in class because the negative is inside with the x, right? So we want to take this point and horizontally reflect it, okay? And then what is the negative 5 doing over here? Then we're going to move that point down 5. So this should be easier than graphing all the transformations because I don't want everything. I'm just asking you what would the new vertex be. Does that make sense? Okay, so let's go graph it. Can I flip this over, y'all? Okay. Oh boy, knocked over my computer. All right, so the original vertex was negative 1, 1, 2, 3, 4. if I flip that point horizontally, reflect it horizontally, left and right, where is it going to be now? Good, Chris. 1, 4. It would be over here, right? And then what's the only other thing I have to do to this vertex point? Down 5. So 1, 2, 3, 4, 5. So it's going to be right here. So what's the new transformed vertex? Sound good? I would make sure you know how to do this. Did anybody do it differently? Good. Okay, tell me what you did. You're getting extra credit. What'd you do? Hey. Mm-mm. What'd you say?
I wrote out the equations and then I just flipped the first, like the x, and I just went down 5 for the y.
Okay, good. Did y'all hear what he said? Sorry, I know y'all got distracted. Look at me. So he said he reflected the x because it said it was a horizontal reflection, right? So instead of -1, he made it, okay. Instead of -1, he made it +1. Thank you, Birdie. Look at me, because this is the easier way to do it. And then he just took the 4 and he moved it down 5. So 4 minus 5 is -1. You can also do it that way. If you're visual and you want to graph it, totally works. Is there a gnat? Oh, I saw you going like this. Oh, okay. Yes, ma'am. Yes, you only need the vertex. Yep. Can I give y'all another one of these to try? Sure. That's a lovely answer. All right. We'll use the same vertex, but now I want you to find the transformed vertex of, let's say, this. Mr. Baker could have done that a lot more discreetly. He done drove all y'all's attention. Are we doing okay, online people?
Yes.
Sorry, there was an interruption. I thought I was about to get in trouble for having my mask pulled down when he was right there. Y'all heard the keys in the door? I was like.
Are we getting the vertex from like the origin or from the -1, 4 that we just did?
So this is the original function f of x. This is its vertex.
Okay.
So that's the original vertex of the original function, and then we're transforming it to this. So I want to know what the new vertex would be.
Okay.
Good question, Maddox. Yeah, that's f of x. And the problem, it said this is the vertex of f of x. So for this, we said it was horizontally reflected, right? So that's going to affect the x's. So instead of at -1, it'll now be a +1. And then if we move it down 5, what's 4 minus 5? Yeah. So this is right 2. So what are you going to do? Add 2. And then what kind of reflection is this? So it affects the y. So what kind of 4 will we have now? All right, so for the new function h of x, does everybody agree we're going to do a vertical reflection? And then we're going to move it right to? Y'all okay with that? Okay, so my new vertex, let's look at our old one. Let's try to do it Brady's way. If I vertically reflect it, am I affecting the x's or the y's? Y's. So my y's, instead of being at +4, are now going to be at, good, -4. Then if I'm moving it right to, what am I affecting? The x's. So -1, if I move it right to, that's +2, right? So now we're at 1. So that would be the answer you would put in. Does anybody need to see me graph it? Easy or hard?
Easy.
Good. You actually learned how to do that in math too. We just did not use that notation. We didn't use function notation. Okay. Questions on the warm-up? All right, get out your homework. Let's go over your homework, and then you have the rest of the period to work on your test review. Can I do 4 and 5? Yes. What else? Does anybody need any besides 4 and 5?
The graphing of number 2.
Number 2 sounds good. Both of you just said that. Yep. Number 2, 4, and 5. Is that it? For your graphs for number 1, what I'm going to do, I did all of them, and I'll just put those on Canvas, and you can go look at the graphs. Does that sound fair? Because I know we chose different ones probably. Okay. Does that sound good, online people?
Yeah.
All right. So I'm going to do 2, 4, and 5. And then we'll talk about what 3 and 6 would be. And then I'll put all of my answers for number 1 on Canvas. All right. So for number 2, what is the parent function?
X cubed.
Good. Y equals x cubed. So looking at this function, we need to list out the transformations. Now, before we even start doing that, what do you guys notice inside the parentheses?
It's not factored.
It's not factored. Good. There's a horizontal stretch or compression, right? So we've got to put it in factored form. Is everybody with me there? Thank you. So -2 bracket, I'm taking out the 3. And what am I left with as my shift? X plus 3, good. And then this whole thing is cubed minus 1. All right, so let's list out our transformations. What do this negative and this 2 do? Okay, vertical reflection. And what did y'all say? Vertical stretch by, good. Are we okay with the outside too? Okay, now look inside. I just said it's inside, so what kind of stretch or compression is it? Horizontal, and it looks like it would be a stretch of 3. What is it really though? Compression of 1/3. Very good. Horizontal compress. Okay. Do you want your, can I hand you your test review? And you can get on and watch this video. All right, horizontal compressed by 1/3. What else is going on? You're welcome. This is the admin night, right? You'll come back. You might come back. I'm not sure.
Probably not, but.
Okay. All right, horizontal compressed by 1/3. We're
3
good?
left.
Good. I just heard somebody say left 3 and
1 down.
beautiful. And y'all probably already said that. I couldn't pay attention to all that was going on. Are we okay? Everybody's good? All right. So now only thing left to do is graph. There's horizontal stretches and compressions, so we need to make what to graph? Tables, love it. What's my parent table for a cubic function? -1, 0, 1. So quiet. And keep going. There we go. She was waiting for y'all to join in with her. -1, 0, 1s. Are we okay with the parent table? Okay, so now you read it left to right. So let's look at this. The -2 was on the outside. It is a vertical stretch. So what am I going to multiply by -2? The y's. Very good. Because it's vertical. Okay, the 3 on the inside was a horizontal compression by 1/3. So that means you are multiplying the x's by 1/3. Do we feel okay with that? Okay, so now my new table for the first two transformations is -1/3, 0, 1/3, and 2, 0, -2. Everybody's good? Beautiful. Okay, so from here, only other transformations we have to worry about are our shifts, right? Because we're going left to right. So you guys said the x's go left 3. So that means we need to subtract 3. And the y's go down 1, so we need to subtract 1. A lot of y'all's tables looked really good. If you messed up, you just accidentally flipped stuff. So my last and final table, so my 3 ordered pairs are -3 and 1/3, -3 and -2 and 2/3. Do I need to slow down on that, or are y'all okay? Okay. And then 2 minus 1 is 1, 0 minus 1, -1, -2 minus 1, -3. All right, so I'm going to go graph those. -3 and then 1/3 up 1, so it's like right here. -3, -1 would be right here. And then -2 and 2/3, -3 right here. And it's supposed to look like a S. Can somebody tell me why the S is so skinny though? Okay, we stretched it vertically by 2, and at the same time, we're also pressing it in 1/3 of the way. So it should be super duper tall and skinny. Are we okay with that? All right, for number 4, you said 4 and 5, right? Sorry, I got distracted. There's a lot going on for my ADHD. All right, for number 4, if we stretch it horizontally by a factor of 2, what should the equation say?
1/2.
1/2. Very good. Remember, the equation makes it look like it would be a compression because it's your x. It's in disguise. Okay? Looks opposite. It's really a stretch. So my equation is going to have 1/2 inside with the x. And then if we reflect it over y, so let's say we're up here in quadrant 2. If I reflect over the y-axis, that's this axis. So what kind of reflection was it? If we end up over here, say it again. Horizontal, not vertical. We're flipping over y. That means we're going left or right, okay? So that's horizontal. So I've got a horizontal reflection, and I've got a horizontal stretch by 2, which is going to say 1/2. So your equation should have looked like this. Square root. Horizontal reflection means negative on the inside, 1/2 x.
It's the same thing if we put parentheses around the x, right?
Like this?
Yeah.
Yeah, that's fine.
Okay.
Because you're multiplying those.
I had that, I just didn't like do the fraction. I had -2.
Got you. Make sure your equation says the opposite. Yep. All right, so number 5, if we want to shrink horizontally by a factor of 1/3, what is my equation going to have? 3. Very good. And then, so horizontal is going to be by 3. Vertically shrink by 1/5. That'll just vertically say 1/5, right? We don't change the vertical. And then if I shift it down 7, that means I should have a -7 on the outside. Agree? Okay, so this is going to be absolute value bars. On the outside, I should have a 1/5. On the inside, it should say 3. And then there's no horizontal shift, so I'm just going to put 3x. Maddox, you can put parentheses if you want. And then down 7 on the outside. Are we okay with 5?
If we put brackets, but we still have the same numbers, will you still count that correct on this?
Like this?
I mean, I had the 3 out of the absolute value.
No, the 3 has to be in the absolute value because it is horizontal. It has to be inside those symbols. So it has to be in the square root, in the absolute values, in the cube, in the squared, whatever. It's got to be inside. Okay. Your test is in Delta Math. So you need to type it in a way that will be accurate. I will go back and look, but I mean, I've typed in all the correct ways to put it into Delta Math. So I am going to turn off where it shows you what you miss automatically because I don't like y'all being psyched out. So some of you liked that feature because you said it helped you for the next problems, but I'm going to turn it off for tests. All right, for number 3, did you guys get f of x equals 3x plus 1 cubed plus 1? Okay. And then for 6, did we get f of x equals, let's see, right 3, reflect over the x is vertical, so negative x minus 3 squared? Beautiful. What questions do you have for me before we work on the test review? Okay, one more time, I need you to listen. This is not like math 2, math 1, math 3. Your test does not look identical to this, all right? But for example, there are like finding the inverses of 3 up here. There might be 4 or 5 on the test. I put the 3 harder ones on the review. Does that make sense? Because if you can do the harder ones, you should be able to do the easy ones. So everything on this review, y'all's is on Canvas, but everything on this review, make sure you know how to do it for the test. There are some problems on the test, kind of like the ones we just did in the warm-up, that are not on the review. That's how you take it up to the college level. Because in college, they don't even usually give you a study guide. So a lot of the stuff on the test, I'd say probably 75% of the test is on this pink sheet. The other 25%, it's honestly like 80-20, will be off of old warm-ups, homeworks, that kind of thing. They're all problems you've seen before, okay? So you guys have the next 50 minutes, not 50, 45 minutes to work on this. Cool? It's due at midnight because honestly, after 45 minutes, you should be almost done, okay?